Hello, hello. So this will be the video, your last video actually, that goes over the exercise is the exercises. So this is for exercise 6 specifically. The main difference between this video and the others is that I'm gonna do 2 tests in this. This particular assignment has the last 2 of the tests that we do in this course in it. So I'm just going to do them both in this video. And then I'll put like a timestamp or something so that you can easily find like which one you're trying to do. That being said, the other thing that I wanted to point out is that this uses a different GSS file. So you'll have to, here we go. You'll have to grab that off of Canvas if you don't have it already. It's the 2018 one, so right here it is in the same spot, just files, SPSS data, bam, there's everything. And the reason being is just that I haven't updated this yet, so it uses the 2018 one. That's pretty much it. So the last 2 tests, which are chi-square and regression, are different from the previous 2 that we did, so t-test and ANOVA, in that t-test and ANOVA look at mean difference. It's looking at the difference between groups. Chi-square and regression look at the relationship between 2 groups. So you're looking at association versus what's different. That being said, the process in terms of like the sorts of things that you are, what did I do last time? Whole page? Nope, that's definitely not it. Page width. There we go. The process is still the same. You're comparing your p-value to the 0.05, whatchamacallit, alpha value. Like it's still, that's pretty much the same. The other major difference is that you can probably see it right here, you have specific dependent and independent variables. So I'll start with dependent. Dependent variables are ones that are being affected. They are the ones being changed by the independent variables. So dependent variables depend on the independent variables. So the change in that is dependent upon whatever's going on in the independent. It's important to make sure that you have them right in your head. Sometimes you can end up doing it backwards. Like you're saying, for example, if you were looking at favorite color between males and females, the way that you would set that up is that the favorite color would be the dependent variable and the independent variable would be sex, would be male or female. Because you're saying, your argument that you were making is that someone's favorite color is dependent upon their sex. It is not possible, really, for someone's sex to depend on their favorite color. Someone's favorite color being green isn't what makes them male, right? So making sure that you have it like, but it could be the other way around, I guess. Let me backtrack a little bit. Someone being male could mean that their favorite color is green. Sorry, I know I jumped around a little bit, but I hope that makes sense. It is hard to kind of keep right in your head at first. So this is another thing that I encourage you writing it down and like maybe drawing arrows, being like, this is the thing that I think is like affecting or like influencing this other thing, so that way you know which is which, like for sure. or just literally just like try to say it out loud to yourself, being like, what do I think is influencing the other thing? I had something else I was going to say, but I forgot it. So instead, I'm just going to show you how to do this. So this very, very first one at the very top, page 1, is a chi-square, right? It tells you right here. Ta-da! Just like with all the other ones, I've given you the variables right here in italics. And so very, very first thing, I've told you we're interested in learning if someone's happiness is dependent upon their sex. We have 2 variables, sex and happy. Happy is a person's general level of happiness, right? So to answer this very, very first question, let me unbold that. Maybe I can move the microphone slightly away from my keyboard. And so your dependent variable is happy, which means that your independent variable is sex. I also remember the thing that I was going to say about variables. Generally speaking, independent variables are things that are, quote, like unchanging. So unchanging is kind of rigid because, for example, education could be an independent variable. Well, you can attain more education, right? Age could be an independent variable, but we all are getting older, right? But these are things that are the fact that you really like SpongeBob is not what makes you 12. But you being 12 could be the thing that makes you really like SpongeBob, right? Like, so you have to think about it that way. There are instances where, like, for example, education could be a dependent variable if you were looking at what factors influence someone's ability to obtain an education. In which case, education would be dependent upon other factors, other independent factors. But you could also use education to measure someone's wealth, their income, things like that. So it just depends on what you're trying to measure, and then you also have to make sure that it makes logical sense what you're saying. Thus, here we have someone's happiness. We're arguing, well, we're testing, I guess, that someone's happiness is dependent upon their sex. That's a lot. Okay. So, just to do the same thing with our null hypothesis here. Also, just to like reiterate, the language that you use is important. So I've seen some people still just say there's no difference. You cannot say that. You cannot say there is no difference. There's always a difference. What we are interested in is looking at statistical significance. However, since chi-square and later in this video regression is looking at association, relationship, whatever, you would say there is no significant relationship between someone's sex and their general level of happiness. That's it. The marker of saying significant is important. The language is important. You have to be precise with this sort of thing because there can be a relationship between these two things, but it might not be statistically significant, which means something else, right? That there's something else maybe going on. There's other variables that are impacting this. So, that's why it's very important to be precise, and I mark you off if you're skipping words or something like that. Again, this is not creative writing. I'm not going to say that you've cheated or something if you copy this exact phrase. This is what you should copy. It should be this exact phrase. So, yeah. There is significant, and we don't put 2 spaces, and their general level of happiness. Bam. So remember that the research hypothesis or alternative hypothesis, whatever you want to call it, is just stating the opposite. And I think, like I said in the previous video, this Velcro thing, like I said in the previous video, you can sometimes have multiple research hypotheses, but I'm just trying to get you in the course of understanding the difference between the two. So, okay, actual test. This one is weird. Chi-square is weird because of course it is. So we go to analyze and then descriptives. Seems counterintuitive. It is the only one that's up here in terms of tests. And you'll go to crosstabs. So again, we get a happy little dialog box that you can make bigger. You can display variable names. And so when you set up a chi-square, the general rule of thumb is that your dependent variable goes in the rows, which is the across, and your independent variables goes in the columns, which is up and down. The way that you can remember that is that an I is up and down, just like a column. So you can see here, I've just went down to sex, and then we have columns right here. This is rows. It used to say rows, but I guess IBM wanted to be spicy. So we've got sex in the columns because that is our independent variable. We sort of already determined that. And then the other one is happy. So that will go right here. The other part that you have to remember, there's a couple of things that we actually do need to change in these like little sidebars. The first one is you'll need to click on the statistics button and actually check this chi-square. Otherwise, it will just give you a table, sort of broken up by those things. It won't test anything. So you need to be sure to check the chi-square box. Otherwise, no test will happen. The other thing that you'll want to do is generally, again, the thing that people expect you to report, if you happen to find any published work with a chi-square specifically, it will be column percentages. So that means that it is tallying based on your up and downs, your columns, not side to side. So column percentages you'll turn on. Everything else, literally just leave it alone. Hit OK, and then we get our little table. So we have this is our first table, and then this one has the actual test in it. So when I'm asking these percentages here, I'm asking for these column percentages. So very happy is 29.1%, pretty happy 55.8, and then not too happy 15.1. So you see where, I mean, it's also like literally the only option, but you can see where I've pulled these percentages from, right? And then the column totals to 100% because it's based off of the up and down, our column. And then literally for females, you will just go and do the exact same thing. So we've got 29.5% here, and then 56.1, and 14.4. Right? I copied the right numbers? Heck yeah. Okay. So that's your first, well, I guess second part, third part. This is 1, 2, yeah, third part. So then we have our actual, like the thing where I'm asking you the test. This little slanty, crazy looking X is for chi-square. That's the symbol for chi. So I'm asking you for the actual chi-square value, which in this case is right here. This is the only row that you need, this Pearson chi-square. The rest of it you can ignore. So the chi-square value here is 0.148. So here, you don't screw up the formatting, and you can just put this. Easy, done. I'm going to leave it. It's going to be ugly. That's fine. Also, and this is just notable for when you're doing your data analysis report, but you see here, it has this little, like, it's an A, but it's like the asterisk. And it says that 0 cells have an expected count of less than 5. That's important. So if whenever you're running your, like if you decide to do a chi-square for your data analysis report, if you have this and it says like 2 cells have an expected count of less than 5, you need to either recode or choose a different variable, something. Because if you have cells that have an expected count of less than 5, it can throw off your results. So chi-square is really sensitive to sample size. If this is like 200, and then this, it was only, I don't know, 4 people, 3 people, 4 people, 6 people, it will show that there's significance, even if there's like that's not necessarily the case. That's just your sample, right? It was just kind of weird. So it's good to make sure that you have a minimum of 5, in all of these. So if this says anything other than 0, try to figure out why it's saying that. Like it could be that you have everything split up too much, right? Like maybe this happy scale originally had 9 different choices, and so it split everybody between those 9 categories too much. So you would condense it down. That's, again, a reason why we learned recoding. So just in case you need to do that. If it comes up, though, if you're running this and you see that it says something, you can obviously email me and we can talk about it. But anyway, I just wanted to draw your attention to that. So we have our degrees of freedom, which, again, I would like to reiterate is a whole number always, even though in chi-square it won't show you anything. But again, in case anybody wants to get creative, again, we're just using our top row. I'm pointing at my monitor, like you can see what I'm pointing at, but it's 2. The way that you determine your degrees of freedom for a chi-square is it's the number of rows minus 1 times the number of columns minus 1. So there's 3 rows, minus 1 is 2. 2 columns, minus 1 is 1, so 2 times 1 is 2. And that's how you know that you got the right number. And then lastly, our p-value, which is in this, you'll always want to look for the word significance, or sig, as in some of the other tests. So here we can see that our p-value is 0.929. So you can see that our significance, our p-value, 0.929, and I'm going to unbold this, 0.929. So 0.93, really, if you wanted to round it, you don't have to. 0.929 is larger than 0.05. Since it is larger, that means that we fail to reject the null. You stop there. Here, that means we would say, I failed to reject the null hypothesis. Our p is greater than 0.05. There is no significant relationship between someone's sex and their general level of happiness. That's it. That's the end. The only difference, if this had been like 0.02, for example, then you would just say, I reject the null hypothesis. There is a significant relationship between someone's sex and their happiness. That's it. Chi-square will tell you that there is a relationship, but it cannot, on a base level, tell you, I'm very sorry if while I'm talking you can hear my cat cleaning her face. It cannot tell you the strength of a relationship, only that a relationship between the 2 variables exists. So that's kind of one of the things. You'll notice that, again, also for chi-square, both of these variables need to be categorical variables. I think I totally and completely skipped over that at the very beginning. So for chi-square, you need two categorical variables. If you think back all the way to like, I don't know, week 2 or 3 or whatever, there's not a lot that you can do with categorical variables in terms of like math. Like you can calculate what a mode, you can get a percentage of people out of whatever, but you can't get a mean, you can't get and things like that. So the types of conclusions that you can draw are limited. There are more complicated ways to attempt to ascertain the strength of a relationship in a chi-square, but we don't do that in this class. And they're also kind of, I'm not going to tell you my opinions about stats tests, but it can be done, but it's whatever. It's a little sketch. So generally speaking, chi-square gives you relationship between two categorical variables, cannot tell you the strength of the relationship, only that one exists or does not. So here, again, we're failing to reject the null, no significant relationship. You're going to pull column percentages. Your independent variable should be in your columns always. And that will also ensure that these percentages are correct because these should be your column percentages. Yeah, there is a second one, so you'll do that on your own. And then also I have a second question for you here after the conclusion. If you changed this 0.05 to instead you were testing to 0.01, I'm asking how that would change. So you would test your p-value against an alpha of 0.01. If you wanted to be 99% sure that your results weren't, just due to chance. So you've got two chi-squares. This is the first one we just did. So then you scroll down and we've got our first regression test. Just like with the others, it is exactly the same. You've got your variables in italics here. And what we're interested in trying to figure out if the amount of time that someone spends with their email is dependent upon the amount of how much they're working, pretty much. So we have email hour and weeks work. Weeks work is like how many weeks they worked in the last year or something along those lines. I should probably know that. It's pretty easy to check. Weeks respondent worked last, how many weeks they worked last year. Okay, so we're saying, or we're trying to figure out if email hour is dependent weeks work. Wow. Okay. So, and that's pretty much what the statement says, right? We're testing if the amount of time you're spending on email is dependent upon how many weeks you worked last year. So, null hypothesis, remember, statement of no difference. There is no significant relationship between the amount of time someone spends on email and how much they work. That is a perfectly fine way to say that. And then thus our research hypothesis, that's a cool typo, would just be the opposite. There is a significant relationship between the amount of time someone spends on email and how much they work. Unlike chi-square, which needs two categorical variables, regression needs two continuous variables. They both have to be continuous because you are calculating mean. If you think about, like literally algebra 1 from high school or middle school, whenever you got to algebra 1, think about, you're graphing a line. Like that's what a regression looks like. with kind of, there's like dots, like your data points are sort of scattered around it, and you're making a line of best fit to see how related those data points are, those little dots. So you need 2 continuous variables in order for that to work. So to do this, we go to Analyze and then Regression, and we are doing linear regression. Bam. We have our happy little dialog box. You're okay. And then, change to variable names. So our dependent variable, we already know, is email hour. So we can go down here, and if you ever see anything that's not a little ruler over here, it's not the right variable. I can tell you that right now. And then weeks worked is this one. The only thing that you need to change is in statistics. You need to check the descriptives box, kind of like with what was it, ANOVA? It won't give you these means and stuff unless you tell it that you want those means. So you'll hit continue and then literally leave everything else alone. You'll hit OK. We get a whole bunch of tables. So we have our descriptives right up here at the top. So the average amount of time that people were spending on email per week is 7.03 hours. And the average amount of weeks that people were working is 34.15 weeks. I think I put hours. Okay. You don't have to change that. It's just my typo. But so we have an average of 7 hours per week on email, and then 34 weeks worked. You can literally ignore these two. What we're interested in is this table and this table, primarily. Well, yeah, these two. So we have our R, which is your correlation coefficient. So how strong the relationship between the two variables is and the direction of it. So you can have like a strong negative relationship, meaning as one variable goes up, the other one goes down. You could have a weak positive relationship, which means that both variables rise together, but the relationship between them is like, if you're imagining a scatter plot in your mind, the dots aren't super closely distributed. They're more scattered than if it was a really strong positive relationship. The dots would be a lot closer together. So we can see here that our R is 0.215. So it's positive. We know that. And it's also kind of weak. 2 is a small number. General rule of thumb that you can use is the correlation coefficient goes from 0 to 1. So anything that is from 0.1 to 0.4, you can say is weak. 0.5 you can call moderate, and then 0.6 to 0.9 would be strong. 0 means that there is no relationship at all between the two variables, and then 1 would be a perfect relationship between the two variables. So if you want to use those values as kind of like a bit of a guide for your strength, that is perfectly fine. I've also seen some textbooks say that like 0.4 to 0.6 is moderate. That's fine too. I don't know. That's kind of weird. But, it's totally fine. As long as you're not telling me that 0.2 is a strong relationship, then that's, I'm okay with it. Anyway, and then obviously direction would be indicated by if there's a positive, there won't be a positive sign, but if there's a negative in front of it or not. So anyway, our R is 0.215. And then our R squared, you actually will use the adjusted R squared. So our R squared is 0.045. Your R squared is also known as the coefficient of determination, which is basically saying how much of the variation in your dependent variable is being explained by the independent variable. So if you turn this into a percentage, so if you just doink this decimal over, that means that 4.5% of the variation, meaning like the dispersion of the data points, your dots on a scatter plot, 4.5% of the variation in email hours is being explained by how many weeks the person worked. That's what that means. Our last thing here is our p-value, which you actually just get from right here. It's in this ANOVA table, and you get regression. Bam. And you can see it's very, very small. So we can just put, like we did with the other ones, it's less than 0.001. As with all the others, other than, I guess, the last, this one, this chi-square, you are testing against an alpha of 0.05. And there's a couple of different questions here, so I'm going to just move that down for the moment. So we know that obviously 0.001 is smaller than 0.05. So you would say, I reject the null hypothesis. Our p is less than 0.05. There is a significant relationship between the amount of time someone spends on email and how much they work. Okay, that's the first question, right? So we have this. If you were rejecting the null, which in this case we are, what does your R indicate? So what is the strength and relationship between the two variables? Like I already said, we have a positive 0.215 or positive 0.22, I guess if you wanted to round it. You could say there is a weak and positive relationship between the two variables, and about 4.5, and then how much of the variation in your dependent variable is explained by your independent variable. So that's what is your R squared, basically. So like I said, you would just change this value into a percentage, so you can multiply it by 100 or move the decimal to the right 2 places. So about 4.5% of the variation in time spent on emails is explained by weeks worked. And here, specifically in this part, I do want you to say the variables. Don't just say, do not just say 4.5% of the variation in the DV is explained by the IV. Don't do that. Do not do that. Use the variables in context, okay? So act like if you were saying this sentence out loud to someone who did not know what the independent variable and dependent variables were. You are just saying this sentence to them, and they should know what you're talking about, at least in terms of the variables. They might think you're insane if you just said that to them randomly, right? But anyway, do not do that. I know someone's going to do it. Do not do it. And then our very, very last thing that I have asked for you to do, what is going on here, is to make a scatter plot. We will go graphs, and then I'm going crazy, and then you go to scatter and dot. Simple scatter is totally fine. So the way that these graphs usually work, and the way that you will set this up, is that the independent variable goes on the y-axis and the dependent variable goes on the x-axis. So we know that email hour is dependent and week's work is our independent. That's it. So now we have our crazy graph, and it looks insane because most people are in this, they're here, right? Like most of the people that were surveyed are not spending a bunch of time on emails, but they're also working a lot. So they're like working class, right? I kind of miss not having emails at my job. So there's a couple of different options here. This is the one that you want, fit line. And you just hit close. I know that this looks insane, but it's making it based off of the equation here, and it puts it where the majority of the like kind of cases are, right? And there just happens to be a few more up here than right down here. So you'll hit close just like with the other ones, and then you can copy pasta that right into Word, or take a screenshot, or anything that is not taking a picture of the monitor with your phone. Whatever option. And I don't know, maybe make this look cute so that it's not, I know that this will fit down there, but anyway, as long as it's legible, like this is probably as small as you would want to go for that. But anyway, as long as this is legible, I'm totally fine with it. If you still somehow don't know how to take a screenshot, please revisit maybe the very, very first video I talk about it, or Google it. Please stop taking pictures of the monitor with your phone. It's like adding extra steps for you. And also, they're like, if you're not going to take it exactly front on, then it's like hard to read. You're like giving your graphs like alien heads and stuff. So please stop doing that. Anyway, so wow, I have a lot of typos in here. Anyway, there is one more regression for you to do. So you'll do that one on your own. It's at the bottom here. And then you have the exact same tasks in front of you. So yeah, 2 chi-square and then 2 regression. And that is your task. I'm sorry that this video is probably very long. I haven't edited it yet, obviously, as I'm yapping right now, but it is probably slightly longer than the other ones. I apologize, but this will have both. And yeah, as always, email me if you have questions, if you're a little confused. I know that independent and dependent variables is very confusing. So if you're like still really not sure which one is which, or if you're unclear as to like why one would be independent versus dependent, something like that, please just let me know and we can talk it out, whatever. But yeah, other than that, I hope you have a good rest of your day whenever you're watching this, and that's all I have for you. Okay, bye.